Determine the local minimum, local maximum, and intervals of increasing and decreasing using technology for the given polynomial function. So here we have a cubic function, a degree of 3 with a leading coefficient of -2. So some things we can tell just thinking about what we've learned previously about end behavior, that we know that the left side of this graph will go up and the right side will go down since we have an odd degree and a negative leading coefficient. But to be able to find these actual values on our graph, we're going to need some technology to help us out. So let's look at this first using Desmos, and then we'll also look at the graphing calculator. So using the free app Desmos or desmos.com, the first thing that I'm going to do is I'm going to type in my function on the left hand side here. So y equals -2x to the third power minus 24x to the second power plus 54x minus 9. So as we take a look at our graph, we can see that it's definitely going off of our screen here. So in Desmos, there's a couple different ways that we can adjust things. If you're on a phone or a tablet, you can just do some pinching to adjust your zoom. Here we can use our zoom out button a little bit. But you can see as we do that, it's changing both the x's and the y's, and so it's starting to look really skinny and kind of hard to tell what's going on. So if you click on the graph settings button here, the one that looks like a little wrench, we can actually select what we want to use as our window, just like we would on a calculator. So while the y values, I think it will be helpful to have large values, I'm going to go from just -10 to +10 on my x's to see what we can see. So as we come back to our graph, we're seeing part of the graph, but it looks like we do need a little bit more than that. So how about we go from -30 to +30. We're starting to see that S shape that we expect for a cubic function. So here's one of the really helpful features on Desmos. If you click on the graph, anywhere on the graph, notice that in gray there are now some points that are marked. We are interested in the local minimum and the local maximum. So if I click on that gray point on the graph, it gives me the ordered pair for that point. So the x is the -9 and the y is the -981. So this is telling us that we have a local minimum of -981 at an x value of -9. If we click here at our peak there, this is telling us the point 119. So this is telling us that we have a local maximum of 19 at x equals 1. Once we've found those values, we can now use that to describe our intervals of increasing and decreasing. So notice that the graph comes down to our local minimum, then it goes up to our local maximum, and then it comes down again. Remember that when we're looking at intervals of increasing and decreasing, we want to focus in on the x values. So we're going to be using the -9 and the +1. So we could say it decreases from -infinity until -9. It increases from -9 to 1, and then it decreases from 1 to infinity. So watch the arrow on the x-axis there. So we're saying from -infinity to -9 is where it's decreasing, increasing from -9 to +1, and then decreasing from 1 to +infinity because we're thinking in the left and the right direction. Now let's look at how we could find those same values using our graphing calculator. If you have a Texas Instruments graphing calculator to be able to do this same problem, we would start by going to the y equals menu on the top left button there and start by putting in our function. So using the negative button at the beginning here, we do -2x to the third power. Be sure to arrow out of the exponent, minus 24x to the second power plus 54x minus 9. Now again here, if we just hit graph, we're going to miss a lot of the behavior of that graph. So I'm going to change the window by clicking on the window button. So we found on Desmos that negative 30 to positive 30 seem to work well in the x direction. For my x scale, I'm going to go ahead and increase that to every 10, so it's going to put a tick mark every 10 units. For the y's, here we used pretty large values when we were looking at this on Desmos. So I'm actually going to look at going from like negative 1500 to positive 1500. And I'm going to do every 100 on my y scale. So now let's take a look at the graph here. So we see that same S-shaped behavior that we saw when we were looking on Desmos, but unfortunately on the graphing calculator we can't just touch the screen if you have a TI-83 or 84 and find those key values. If you have a TI-Nspire, you can click on the graph and find some of those key values. For the 83 and 84 family, we want to go to this Calculate menu. We get there by hitting second and then Trace is what takes us there. And so we're first going to do this option of minimum. So you can arrow down or type the number 3. And it asks you some questions. It's asking you for the left bound. And so we're going to move using our left arrow over to the left side of that local minimum we're interested in and hit enter. And then it's going to ask for the right bound. So we're going to use our arrow key and move over to the right side, hit enter. You can move the cursor closer for the guess or just hit enter. Notice that the calculator here is doing some rounding, so it gives us negative 8.9 repeating. So that's that same negative 9, negative 981 that we saw in Desmos. So it's telling us we have a local minimum of negative 981 at an x value of negative 9. To find our local maximum, we'll go back to that Calculate menu, so second, Trace, but this time we're going to pick the option for maximum. Same question, so I'm going to use my arrows to move over closer to the point I'm interested in, hit enter for the left bound, move over to the other side, hit enter for the right bound, enter for the guess, and our cursor will move to that point on our graph. So this is approximately x equals 1 with y equals 19. So we have a local maximum of 19 at an x value of positive 1. And again, we see our decreasing from negative infinity until negative 9, increasing from negative 9 to 1, and then decreasing again from 1 to infinity. So if you're working in your graphing calculator, anything in the TI-83 or 84 family, this Calculate menu is how we can find intersection points, maximums, minimums, and zeros. So just to see how we could then write these answers, our increasing and decreasing intervals, we would give those in interval notation. So we could say this is increasing on the interval from negative 9 to 1, and our decreasing, we'd have 2 intervals joined with our union. For the local min and local max, we can give what that output is as well as where it happens. So a local minimum of negative 981 at x equals negative 9, and a local max of 19 at x equals 1.